I'm Anil Kumar, and in this video we will connect power functions with their graph. The question here is, state possible equation for a power function whose graph extends from quadrant 2 to 4. That's part A. Part B is the graph extends from quadrant 3 to 4. Then we have from quadrant 2 to 1, and part D is from quadrant 3 to 1. What I really want to say here is that if we have a graph, let's say something like this, since we are saying it is a power function, let's understand what is a power function. Power function really means a function of the form y equals to a x to the power of n, right? Where a is any real number, a belongs to real numbers, and n belongs to whole numbers, right? So that is what a power function is. So always this graph will go through the origin. That's very important. If x is 0, y is going to be 0, correct? When we say that the graph extends from quadrant 2 to 4, this is quadrant 1, this is quadrant 2, 3, this is quadrant 4, right? So graph extends from quadrant 2 to 4 means from here to there, right? So that could be a graph something like this. Is it okay? So that kind of a graph. This is the graph which extends from quadrant 2 to 4, right? Let me sketch the other graph for you also. Quadrant 3 to 4. 3 to 4 really means this is quadrant 3 and that is 4. So something like this. Is it okay? So that is how it could look like. So the question here is, state possible equation for a power function whose graph extends from quadrant 2 to 4. So if graph extends from quadrant 2 to 4, then what could be the equation for a power function? Well, in this case, since the right side is down, the leading coefficient is negative. So we could write this as y equals to negative. And since both the ends are opposite ends, power has to be odd. So we could write this as x cubed, for example, right? So that could be a power function represented by the graph. Now here, right side is down, so the equation should have negative leading coefficient. Since both are on the same side, degree has to be even. So it is x to the power of, it could be x squared, for example. So that is how you could write a power function from the given graph and given end behavior, I should say, right? So what we are giving here is kind of end behavior. So when we say from this to this, it means end behavior. Is it okay? Now, so the other two could be, let me just sketch here, and then we'll write down equation also. Extends from quadrant 2 to 1, so that is kind of like this. Is it okay? Okay, right. And here from 3 to 1, so both are landing in quadrant 1. As you can see, both of them land in quadrant 1. Now that means the leading coefficient is positive, correct? And therefore, a possible equation could be y equals to, so positive here, no need to write plus. Both same sides means even degree. So we could say x to the power of 4. It could be 2, 4, 6, whatever. Coefficients could be half, 1, 2, anything, right? Now in this particular case, again positive. Opposite ends, right? So this is opposite ends. Therefore, the degree of this polynomial should be odd, and we could write this as, for example, x to the power of 5. Do you understand? So this is how you could relate the end behavior, graph, and the equation. I hope the concept is clear to you, right? I'm Anil Kumar. You can always share and subscribe my videos. And if you like, put a thumbs up. Thank you, and all the best.